All right, so confidence interval for paired t-test, scenario 2. This is page 143. We're revisiting Andy McNeil data. And because we're using the old data, I will blow through the conditions fairly rapidly. So Professor Andy McNeil, or Andy Neal, measured the time in seconds required to catch a falling meter stick for 12 randomly selected students, dominant hand and non-dominant hand. Professor Neal claims that the reaction time in an individual's dominant hand is less than the reaction time in their non-dominant hand. Now, key here is for student number 1, they were tested twice. Student number 2 tested twice. So all of these were tested twice, which means I have paired data. So I need to take a moment and enter these into L1, the dominant in L1 and the non-dominant in L2. Could you swap the order? Yes, but if you do, you're going to get different results. So you have to say which order you went. So stat edit, and I have my data in L1 and L2. I'm going to go up the top of L3, and to get there, I just press the arrow button. Make sure that's highlighted. Then second 1, because L1 minus second 2. So that's dominant minus non-dominant, and I press enter, and it populates it for me. All right, so that's populated that data for me, that my differences. And it says create a 97% confidence interval for the mean difference and explain the confidence level. All right, so here they're telling me I have to do the repeated sampling, and we always have to give the conclusion. So let mu d equal the true population mean difference in reaction time. Which order are we going? We're going dominant minus non-dominant. If you swap the order, that's fine, but you're going to get a different result. Your interval width will be the same, but it's going to switch from negative to positive or vice versa, right? Depending on the order, it will switch what our range is. So it's really important that you always define what you're doing. And since I'm doing not dominant minus non-dominant, I encourage you to do so as well. The first condition was random sample. It was given. 12 is less than 12 divided by 0.1 is 120. Reason we'll assume that there are at least 120 students. The sample is less than 10% of the population. Then we need to check the differences. This is the new condition. Differences are independent. Well, I'm going to once again assume that student 1 change in speed is not different than is independent of student 2, that everyone's is independent of the others. So differences in reaction times are independent. Reasonable to assume that one person's reaction time does not impact that of the others, and that seems reasonable to believe. The next thing is normality. They didn't tell us it was normal, and we only have 12 pairs. If we had 30 or more pairs, we could say it's normal by central limit theorem, but we don't. So we've taken a moment and I went ahead and calculated this. So I need to do a box plot. Second stat plot. Press enter, arrow to the left, drop down, arrow over, press enter on the one with, oops. Make sure you press enter with the one showing the outliers. Then I need to drop down to my X list. And my X list, I'm looking for the paired, so this would be second 3. Then I can press zoom 9. Now, my calculator glitched. That's not unusual. If it does, press clear, then press zoom 9. I don't know what causes it to do that, but sometimes it will. I look and I see that I have no outliers. And then I can use the trace feature so I always sit there and go, okay, I'm going to sketch the shape. So I kind of sketch the shape to the best of my ability. And then I'm going to use the trace feature to get the major points. And so we sit there and go, okay, the lowest is negative 0.043. Then we have a negative 0.0235. negative 0.0145, and I can't draw a scale that accurately. So all I did was take those values and labeled the major points, and that was good enough. All right. Well, the formula is going to be x bar d plus or minus t star sd over the square root of n. Well, we know n is going to be 12 because we have 12 pairs. That also means our degrees of freedom is going to be, in this case, 11. And we need to get x bar d and sd. So here's the way I do that. I press stat, calc, one variable statistics. My data list is in L3, so second 3. And I end up getting x bar d equals 0.0131. And I get SD equals 0.0164. Now, the one thing that I'm missing is my T star. So we need to go about getting T star, second vars, inverse T. And in this case, they gave us a 97% confidence interval. So parenthesis, 1 minus 0.97, close parenthesis, divided by 2. Degrees of freedom, which are going to be 12 minus 1, or just 11. And a calculator is thinking about it. And it gives me a T star of 2.4906, which I can now plug into my equation. And I have negative 0.0132 plus or minus 2.4906 SD over the standard deviation. Over the square root of the sample size, which in this case was 12. Now, stat, test. If I scroll all the way down to number 8, I get a T interval. I need to make sure data is highlighted. My data is stored in L3, so second 3. And I need to change my confidence level to 0.97 because they wanted a 97% confidence level. And there's my interval, negative 0.025 and 0.0014. Negative 0.025 and negative 0.0014. So we are 97% confident that the true population mean difference in reaction time, which order, must have this always, dominant minus non, lies within the interval here. All right. And explaining what the confidence levels is. In repeated sampling, we expect that this method will capture the true population mean difference in reaction time 97% of the time. Once again, always have to show the direction. Finally, is there enough evidence to show that this worked, or that Professor Neal is right? Well, 0 does not lie within the interval. Therefore, we are 97% confident that there's a difference in reaction time, dominant minus non-dominant. So basically, we just showed that Professor Neal was correct. There is a difference in reaction time from dominant to non-dominant. We're saying dominant is faster, and we can say dominant is faster because we have everything lies below 0. All right. The next video will be hypothesis for scenario 3.